Hi friends, today I'm going to show you a standard problem which is often asked in interviews. This is based on linked list. Uh, I'll not give you a complex problem right away on linked list since we are just starting to learn and understand how to solve problems on linked list. I'll show you on simple single linked list how do we how do we achieve or stage our solutions to achieve our goal. So first let me give you the problem statement. So as you can see, this is a single simple linked list where you have a node with value and a next pointer. So the node can be represented as this forms your simple single linked list. Now I'm complicating this a little bit to make it eligible for an interview question. Assume instead of single links, we have option for two links. We'll modify the node structure as so. As you already seen, next is pointing to the next node, but our random will point to a random node. It can point to anything. So you can assume this is pointing to the first node and this is pointing to itself. This is pointing to V3. Now what is the problem? This is the setup. Problem is copy the given linked list in memory. So what you have to do, we have to create a copy of this, right? This is the question. Now how should we approach this? So whenever we try to solve any problem in interviews, you have to do two things. You have to stage your solution so that you do not jump into a final conclusive solution and get stuck there. So think of a simple sub problem to solve, and then we can add more constraints and keep adding all the constraints, input constraints, output constraints, and additional decorations one after another. So first we solve the basic problem and then we go more deep into solving the actual given problem. The second thing is you need to think aloud. So whenever you solve something, just do not be silent, do not go into silos. You should always think aloud, and whatever procedure wise or step wise you are thinking, you should actually write those, or better tell those to the interviewer, and then try to think along or together, right? Now what am I thinking on this, right? So let's first remove the random uh, pointer. So that is the one which is creating all the nuisance, right? This is the one which is creating all the issues while copying. Let's copy simply. So if you simply want to copy, what do you want to do? We create a index, we iterate. So I'll write a pseudocode here. While right, what do you want to do? Next to new node, take a index dot value. Okay, now I'm just giving you the idea. The actual code I'll post in and follow up video. So this is just the idea. So you go one by one, you create the list from left to right, and eventually you should have head v1, v2, v3. We'll assume random is pointing to null in this case. So this is all set. Now our randoms are pointing to null. How do you fix this? Now if you look at this current solution, as of now it is order of n, because we definitely need to iterate once from left to right. Now if you try to set the random, you see what this is doing. So v1's random is going to v3, right? Even if we again start iterating using this index, so you'll see v1 or index nodes random is going to v3. So let's try to do it. Naive approach. Index 1, index 2. Now iterate here and try to set the random here, right? So index 1 is going to v3. We are in v1, but we don't know what is v3 or corresponding v3 dash, right? What is v3 dash? Or the new v3? We don't have any pointer. Here is a pointer to v3, but there's no pointer to v3. If we go by the trick that it is offsetted by positive 2, that is, we are skipping 2 nodes to actually reach v3. So we have to do a lot of calculations. So you have, instead of directly accessing by the pointer, you have to understand what is the number of nodes and iterate, and similarly iterate here. And as you can see, if we go to v5, understanding how many nodes before the node is pointing is very tedious job, since in linked list you cannot come back. So you have to start 2 pointers and employ some other algorithms to understand how many nodes back it is, and similarly here the issues will be same. So what we eventually need. So seeing this situation, right, what we need should be a map of what, you'll ask me. So map should be between corresponding old and new, right? This is old, this is new. Old is v1, v1 dash, v2, v2 dash, v3, v3 dash, v4, v4 dash, v5, v5 dash. How will it help me? Now, when do we initialize a map? We initialize the map whenever we are on the first step, right? This is step number 1. So whenever we create new nodes, we insert the index and the new node in the map as key and value. Now, how will it help us? Step 2, we'll do the same thing. We'll go by index and go by index 2, and once v1 is pointing to v3, we'll take this v3 and search it here. We go to this index, we get corresponding v3 dash, and we point v1 dash random to v3 dash. So what we do? Get, we'll say map.get. Remember, it is pseudocode, so we are not writing the actual code now. Map.get v1 dot random, right? This is the, now what we do, we got v3 dash here. Now v1 dash dot random equals to previous value, correct? Now again you iterate, you can do index 1 plus plus, index 2 plus plus. This will definitely solve your problem. Now, what is the disadvantage? There is no disadvantage. Like if you, nowadays there is no limitation of space, right? So what you are doing here is iterating the list 2 times. So it will be a 2n order, which is again order of n, but space complexity is also of order of n. You cannot reduce the space because you need the mapping between 2 nodes as well. So this space complexity is not including the space which you are creating or copying, because that is what the problem asked. This is between the transaction, right? While doing our algorithm, how much space we are taking. Now, how are we going to solve this? Like if somebody tells us we shouldn't use that much space and you can use the same amount of time, how do we do it, right? So what is this mapping? So if you can think analytically, this mapping is kept just that we can traverse from v1 to v1 dash or v2 to v2 dash. We need to understand like what is the corresponding node. So one trick that we can do here is, you have your nodes like this. Right? Now let's create the new linked list within this linked list, and then we can see how do you separate it. So what I'm going to do is break this link and insert the new node here itself. Similarly, break this link, insert the new node here itself. When you write code, I'll show you how do we actually do it, but this is very simple. If you have reached to this stage, I'm sure you can definitely write the code on your own, but I'll do a follow-up video with the actual code as well. Right? This is your modified linked list. Now once you have set up, this is a stage 1. Insert corresponding nodes. Stage 2. Now set the random pointers. So assume your initial random pointers were v1 going to v3, v2 going to v1, right? v4 going to v4, v5 going to v3, right? I should have drawn in some other color, but yeah. Now again, what do? You start iterating. If you see index random pointer is pointing to v3, you do index.next random pointer should point to index random pointer plus 1. For example, random to index dot random with old random, right? Now index dot next dot random equals to old random dot next. Why does it work? Because whenever it points to a random, the next node should be the new random, right? And this should work. Index plus 2. Again, this is pseudocode. At the end, what should be the third step? Once we have this, the third step would be to actually separate out the lists. Again, from this list, you are breaking it. So you eventual list will be v1, v2, v3, v4, v5, and your new list will be v1 dash, v2 dash, v3 dash, v4 dash, v5 dash, and randoms will be definitely working. Right? How to break this? Again, iterate and break odd versus even nodes. How to actually write the code? I'll follow up with a video having the exact code. Right now, let's discuss on complexities. What is the order? First step is you are iterating from left to right, so which is of order of n. Second step, you are again iterating to set the random plus order of n. Third step is you are again iterating from left to right, order of n, which is of order of n, and there is no extra space that we are consuming in this approach. So friends, this is a very tricky question, and if you don't go stage wise to approach your solution, you will definitely get jumbled and you will not reach to the correct solution, right? So this should be your base, and try to modify your thinking or train your thinking to actually think this way and solve these kind of problems. Yep, so that's it for today. If you like this video, please subscribe, click the bell icon so that you get notified on the next videos, and definitely like this video. Thank you.